Hello, my name's Dr. Jonathan Sauder, and I'm a Senior Mechatronics Engineer here at NASA Jet Propulsion Laboratory. And a lot of what I get to work on is how things move in space. And specifically, I work on deployable structures. Now, what is a deployable structure, you may be asking? Well, I've got my toys here to help out. And I love toys because it allows you to visualize things in ways and point to things that can really help you understand things. So, as you know, this right here is a rocket, and at the top of the rocket you have the fairing, which is where the payload or what you're launching into space sits at. Everything else below this is all fuel to get it into space. Now what that means is that you have a very, very constrained volume at the top of the rocket to fit the satellite or object that you're launching into space. But once you get into space and you have separated from the rocket, typically what you'll want to have is the spacecraft will need to expand. Maybe the solar panels need to open up, as shown here, to be able to generate enough power to operate the spacecraft. Or maybe an antenna needs to open up to start taking some very critical data. But one of the things that's incredibly challenging about a rocket launch is that the rocket launch itself is extremely violent. As this is launching up into space, things are shaking all over the place and moving. You can experience up to 100 times Earth's gravity, or even more, in a rocket launch for different components on a spacecraft. What that means is everything needs to be held in place in that rocket launch very, very well. You don't want these satellite solar panels flapping and opening up during the launch. You want them to be held secure. But then once you get into space, you want that secure feature, which is holding these things in place, to allow things to deploy and open up. Hence the name of this challenge, Let It Go.
So these are all different types of separation devices which allow spacecraft to let things go. The goal of these release devices is you start off with something that's one component, like this assembly, and then by triggering a certain action, it then allows the two components to separate and get pulled apart. Let's take a quick look at three current separation devices. This first one is called a cable cutter. It is designed to cut a cable that is this diameter, and it does that by driving a sharp knife blade from the chamber through the mouse hole, severing the cable. This is driven by an explosion, which of course creates a high shock event. The next device here is a shape memory alloy device where shape memory alloy expands, causing a bolt that goes through this device to break, allowing two elements to separate from each other. And this device is a separation nut, which basically upon firing a pyro, separates some threads which are inside the hole here, allowing a bolt to release. One of the key challenges with all of these devices is that all of them create very high shock events when they activate. Another challenge that you can see is the size. While these work great for large spacecraft, you can imagine that if you're on a very, very small spacecraft, it might be challenging to implement some of these.
So, your challenge this weekend is to design a device which can let things go without a bang. Try to come up with a low shock release device. Ideally, it could hold about 4,000 newtons of launch loads, and then separate with a very low shock event. We're looking forward to all the creative ideas that you'll put out there. The rest of the challenge details are, of course, on the Space Apps website. I should note, any of the requirements are entirely optional, but it gives you a little bit of context to the environments and conditions that this device will be used in. I look forward to connecting with many of you in the chat room, and good luck.